Hello everyone. Today I'll be talking about a few more functions than you already are familiar with. For example, we've already discussed in class the delta function, unit step function, unit ramp function, sinc function, the sine cardinal sinc function. Let us just quickly discuss a couple of ways certain functions can be defined so that they may be helpful when you want to express a certain function in a concise and a compact way. So for example, one of such functions with which we are already familiar is the sinc function. So sinc of x is in some literature defined as sine pi x by pi x, or in some other literature you will find it to be defined as sine x by x. Both definitions are correct. In our course, we will be following this definition. The literature that uses this as the definition of sinc often describes this function sine x by x as the sampling function sax. Now when we discussed Fourier transform in class, we learned that if this is the Fourier transform of a certain signal, then that signal is a sinc function. Defined as sine wt upon pi t. Now if I ask you to define sine wt by pi t as sinc of some argument, that means you want to write sine wt upon pi t in the form of sine pi something upon pi something, and then that something would be the argument of your sinc function. So in order to do that, we would have to rewrite the numerator to bring in pi in the picture. So I can write it as sine pi w by pi t, multiplying and dividing by pi. Now this tells me that I can write my sinc x in the form of sinc of w by pi t, but I need to make the denominator also pi w by pi t. In the denominator I already have pi t. That means all I need is w by pi. So I multiply and divide by w by pi. That means this function can now be written as w by pi sinc of w by pi t. What this tells us is that this number with which your sinc function is multiplied with, this is the value of this function at t equal to 0, and this is also what you would get if you simplified this expression to find the value at t equal to 0. You would have to use the L'Hopital rule, and you would find that at t equal to 0, this function converges to w by pi. That is this argument multiplied with the sinc function. And the zero crossings of this function, if you try to find it mathematically, wherever wt is a multiple of pi, at those values you will find that this function will cross the zero axis. That means at t equal to integral multiples of pi by w, you will find that this crosses the zero axis, and so on. Directly from the sinc function, you can see that whatever is the coefficient of t, w by pi, you'll find that the inverse of this, that is inverse of w by pi or inverse of this coefficient, is where the zero crossings of this sinc function would be. So for example, if I said sketch a signal xt which is 2 sinc of 5t. If this is the function that is given to you, this is obviously a sinc function, so at t equal to 0 its value will be 2, and its zero crossings would be at integral multiples of 1 upon 5. So 1 upon 5, 2 upon 5, 3 upon 5 and so on, or minus 1 upon 5, minus 2 upon 5 and so on. Can you prove this mathematically? If this is how the function is defined, this means that this function is 2 sine 5 pi t upon 5 pi t. Using the L'Hopital rule, differentiate the numerator and denominator and substitute value of t equal to 0. That will give you 2. For all other t not equal to 0, if you want to find where this function becomes 0, that would mean that this angle 5 pi t would have to be an integral multiple of pi. So that means 5 pi t would have to be some integral multiple of pi. That means at t, which would be integral multiples of 1 by 5, is where this function is going to cross 0. So this is what you directly get if you looked at the definition of Sinc. This was about writing Sinc function in the form of an argument. There's another function that we very commonly come across, especially in the course of signals and systems, and that is the rectangular function. A rectangular function is also called a gate function or a pulse, and it is represented as rect of some argument. Rectangular function. Saying that some function is of the form rect t minus a upon b, what this means is that this is a rectangular function, a unit rectangular function having a value equal to 1, so multiplied by 1, centered at the value of t equal to a and has a width b. So this kind of a function, it is centered at a and has a width of b. So a very commonly used rectangular function in our course is when we try to find the Fourier transform or inverse Fourier transform of a Sinc function, and we know that that is a rectangular function, but how to represent it? So we know that if you have a function xt whose value is 1 between minus t1 and plus t1, its Fourier transform is defined as 2 sine omega t1 upon omega. In terms of a Sinc function, I can define this. How to write it in terms of a Sinc function? So I know that its value at omega equal to 0 is 2t1, and it crosses the horizontal axis at every pi upon t1, 2 pi by t1, and so on, multiples of pi by t1. So I can write this as pi by t1 omega. If this is how you represent this in the form of a Sinc function, what is this the Fourier transform of? Till now we have been representing this as something like this: xt is equal to 1 for mod t less than t1 and 0 otherwise. But what if I want to represent this in a concise form? I could use the rectangular function, and here that would mean that the width of this whole function is 2t1, right? So I can write this as rect, it is centered about 0, so rect t upon 2t1. So if I wanted to represent Fourier transform pair purely in terms of functions and not in terms of function definitions, I could say that rect of t upon 2t1, the Fourier transform of this is 2t1 Sinc of t1 by pi omega. In general, in future, whenever you come across a rect function, you should know what that rect function means and what does this argument mean. It must also be noted that typically we would say that the value at minus t1 and t1 is undefined, or we would say it's either 1 or it's 0. Typically, while defining rect functions, say of the form t by tau, this means this is centered about 0 and has a total width of tau. That means it varies from minus tau by 2 to plus tau by 2, has a value 1. So its value is 1 for mod t less than tau by 2. Its value is 0 for mod t greater than tau by 2. But at t equal to tau by 2, its value is the average between whatever was the value before and after. So its value is half at t equal to tau by 2. This is how typically a rect function is defined. A third function that you would come across is the triangular function. Tri of t by a can be defined as 1 minus mod t by a for mod t less than a and 0 otherwise. This is for a not equal to 0, because a cannot be 0 in this case. So say for a equal to 1, if I am looking at the function tri of t, that means a is equal to 1. What this means is, this is 1 minus mod t for mod t less than 1 and 0 otherwise. So if you look at this first term, what this means is, if you take plus t in this definition, then the function becomes 1 minus t if plus t is less than 1, and if you take minus t, if you take negative t, this function becomes 1 minus t, that means 1 plus t for minus t less than 1, or in other words, t greater than minus 1. And it is 0 everywhere else. So as a function of time, as a function of variable t, this term is a straight line having a negative slope and a y-intercept of plus 1. So if I try to plot this, for t less than 1 and t greater than minus 1, this is my area of interest. I know already that the function value is 0 everywhere else. So for t less than 1, the function value is 1 minus t. So this is a straight line having a negative slope of minus 1 and y-intercept of 1. That means something like this. For t greater than minus 1, that is this interval, I know that this is a straight line having a positive slope of 1 and a y-intercept, a vertical intercept of 1. So this is how a triangular function can be defined in a concise way. Instead of having to define a function elaborately for different values of t in this form, you can simply define this whole function in terms of one term, and that is tri of t. Just how you could represent rect of t. It should also be noted that when you perform convolution between two rectangular functions, you would get a triangular function. Another way of defining a triangular function is in this form. Some literature define tri of t as rect of t by 2 multiplied by 1 minus mod t. Now 1 minus mod t would mean 1 minus t for positive values of t, that means t greater than 0, and 1 plus t, that means 1 minus t when t was negative. So something like this. So when you multiply the two, rect t and 1 minus mod t, which is the same as the definition of triangular function of t that we saw before. Triangular functions can also be represented with this function delta t, and if I use the alternative definition where I say that if I say delta t by a, in the previous definition a used to mean the half of base width. That means if I was defining a equal to 1, what I meant was half of this base width was 1. So the base width was actually 2. But in an alternative definition, which is also very popular, this a represents the total base width. That means if I was to say that a is equal to 1, this would have to mean that this entire width was 1. So with that definition, if I define a unit triangular function, that means a triangular function having a base of unit length and a height of unit length, delta t would be defined as 0 for mod t greater than equal to half and 1 minus 2 mod t if mod t was less than half. This term means that this is 1 minus 2t when t is less than half, and this is 1 plus 2t when minus t is less than half or t is greater than minus half. So t greater than minus half is a straight line having a slope 2 and a y-intercept of 1. This term is a straight line having a slope minus 2 and a y-intercept of 1. This is how a unit triangular function looks like. In this definition, delta t by a is the total width of the base of this triangle, while in the other definitions, this a is half of the width of the base of the triangle. Thank you.